How's it going, everyone? Welcome. Elvira Gonzalez here. And today let's go into now make a quick recap of how do we get here in this course called now Intro to SQL and Postgres, as a way to first, understand what's the problem that SQL solves, right? And the specific goals in today's course, which is taught by Brian Hall. And this is not only to went through this particular course and never do that again. The reality is that I want to be able to describe all the things that I know, the problems, the tools, and then have a practical approach when it comes to actually interact with the Postgres or the SQL engine, right? Database engine. So the problem or this course is first layout in this way. All right, so we have now the introduction, the database and table, the SQL commands, joins and constraints, JSONB, aggregations, function triggers and procedures, the movie database, as well as query performance. I actually add this as it is. So how can we optimize our queries and what are the techniques to do that, which is something that actually described here. Query performance, views of queries and array, transactions, window functions, and self-join. So why are we doing this? Because as the industry evolves and the business evolves, we are not only useful, or we cannot, the value that we provide as developers is going to be able to define user interface as well as working with the database. So the front end, that you must have knowledge about the front end, as well as the back end, how you can set up an API and what is the role of an API, which you can think of this like a bouncer at the database club. And now the database, what it does, what is the problem that it solves, how many type of database do we have right now. We're only going to focus on one, which is the SQL. And what are the problems that now, for example, relational database, usually, particularly the SQL solve, and then how can we now dive deep into this by understand what this tool works, how this tool works, all right? How can we use to solve developers or company problems, how to set up your first database, which is pretty straightforward, okay, using Postgres. Okay, how to set up your first database, how to think about going data into the tables, all right, and the best way to query your data for your app. So if you can think of this like if you have multiple tables or multiple places where you can store now data, pretty much like this, right? You can think of this as one table, one recipient, okay, where you can put all of the data that is relevant for this container, right? For this car box. Let's say, hey, I want in this here hold all of the users, for example, right? And in another one, I want to store is user seasons, and another one is the products, and another one, and you get the idea. So with that, right? Now we're going to see what is the best way to query your data, and especially if you have all of this stacked together, or do you have multiple places where you can where you need to look at it. All right, what will be the best way to query your data, and how to identify slow queries and optimize a slow query, which is the reason why you are getting paid for. You know, this is why you are getting hired. And then how to connect your SQL query with a Node.js server. This is for this particular issue, but then we're going to look at how can we connect SQL queries to other applications, let's say a C# or a Visual Studio or PHP, actually is the same, right? So they have their own particular libraries that we can now import here and start to work with. And then now you write your SQLi, right? So let's get into this. We went through a little bit of introduction to understand what is the problem that SQL is trying to solve, which is the data chaos, okay? Because prior to SQL, since every database system has their own cryptic language to interact with the data, and the data is very hardware specific, meaning you have one particularly database. It's not the data, it's a database system. So those database systems are hardware dependent, all right? And then you need a programmer to do to interact or to manipulate this data in an effective way. So now with this SQL language, well, it democratized the way of how now we can manipulate that. So that's one of the reasons why we can, or marketing people can now interact with the data without needing a computer science degree, okay? And as you can see here, this is part of the trend of the computer science, right? Is building layers upon layers upon layer of abstractions that only if you are a computer science you want to interact with, or you need to interact with, but it makes it much more easy to access to whoever, as long as they have the desire or a business to build. Now, yeah, that's good. So part of the requirement here is to look at the internet fundamentals and how now the client, the server architecture, what it is, and how the browsers and inside of the computer works, and then how they send that data to, or how they request data first initially to the DNS, and then once it has the proper direction, where to send that request, which door it needs to knock, then it's going to send that request to the proper computer outside in any other place in the planet, right? And then that computer, aka the server, process that and then send that response back to the client. And to make that communication possible between two different computers that they might have the different architecture, different way of how they organize their processing units and memory and their input and output devices, right? Because of that, now another standard born, which is the OC model. This is which stands for Open System Interconnections. So no matter how those computers architectures are, we don't care about that. The only thing that we care is that we have now a standard to exchange data. This open system interconnections, right? And they have 7 layers. It all starts with the application, all right? When it's allowed to communicate to so the application layers allow the users to interact with the networking services, okay? And then on the presentation is where the data is treated and transformed into a format that is usable. On the season layer, it's all right, now that I have this data in a usable format, I need to know where I'm going to send that and which port I'm going to send it. So this is when the port the port management and system management is established. And something that I missed on the presentation layer is that not only that it passed through a usable format, but also this is when encryption happens according to Cloudflare, right? So you have now the application, the presentation, the season, and then you also have is the transport layer, which say, hey, what will be the protocol, the set of rules that we need to use in order to send this data. It can be UDP, all right, or it can be TCP, where now I need to be aware if I can send this data, and whoever is on the other line, they need to be there, right? TCP, connection based. Or UDP is like, hey, I can talk and talk and talk and talk, or send data, and I don't care if the other person or computer in this case is on the other line. It's on the other side of the line. You know, I'm going to talk until somebody can hear, you name it, right? This is useful for VOP, video over IP, as well as audio. And in this layer, in the transport layer, it's defined that. And then we have now the internet, which is defining is what is the physical path that this data will take, all right? And each one of those devices, computer, has their own IP address as well as a MAC, all right? The MAC address is, this is for the device, the medium access control, all right? And then you have now the way of how you're going to transmit this data between closest devices. This is when you have now the data link layer. And then you now have is the raw or the physical medium, where now the raw streams of data or strings of octet is going to be sent over, right? So, okay, this was a quick overview of now what's going on. And well, now that we describe that, all right, the process in which now the communication is established, especially with TCP, is, hey, I'm going to say now a sync synac act, right? So it's the first step to establish a connection, the handshake, right? So you have now the sync, where the client send the sync, the server receive that, and then is sent back the sync synac to the client. The client say, all right, good. Now I'm going to send now a acknowledge, the ACK, to the server, and this is when the communications without encryptions happen. So if you want to now establish an HTTPS connection, okay, this is also something to recap that. Let me nope. Let me go from the front end system design like this. All right. And the front end system design, the part of where we talk about the application state and connectivity. What? Okay. It's this one. When this is how you can normalize your data and yada yada yada. Network connectivity. Here we describe is the OC models and what's happening in each one of those layers. Okay, as I mentioned before. So the transmit data using the protocol UDP, which is connection based. When SYN SYNAC, the handshake happens, or UDP, connections with no data, handshake negotiation, great for VoIP. Okay, and this is, let me see if I can find this one, exactly this. TCP based connections versus quick UDP. This is what happened when you use now TCP plus the TLS, which is the transport layer security, as a way to say, hey, once we establish the handshake in the TCP connection, we also want to now is set the secure communication or encrypt the communication, right? So this is when you have things like this. So after the TCP handshake happens, Cincinnati Act, all right, is going to also send now a client hello. The server send now a certificate, the server hello with some SQAX, right? Once it receives that data, it say, okay, I'm going to exchange now the key for this, and I think this is part of the important. This is part of this thing is quite important. Let me actually understand this. This is the TLS with claw. What happened? Or you can say describe in the most succinct way possible the TLS handshake, right? Exactly, it's a 4-step process. So you have now the client hello, the server, a client sends supported cipher suites of and random numbers. The server hello, which is happening after the acknowledge, all right? Ooh, what happened here? The server's hello choose cipher suite, send certificate cipher suite, which is happening here, cipher suite or suite kit, right? What is the acronym uses in the exchange? Or what are, no, what is? Exactly, secure socket, certificate of authority, public key infrastructure. This is quite interesting because this diagram, something like SKA exchange. Server key exchange. Okay, it makes a lot of sense. So here now, once the acknowledge is about to be sent, it also say now a client hello, which is here. A client hello sends a support cipher suite in random numbers. Okay, the client hello, the server hello say, I'm going to choose this specific cipher suite and send a certification. Okay, send the certification. Send the certification, the server hello, and the exchange key exchange, the server key exchange. The client receives that and now sends the client exchange and some certificates. Okay. Client verifies certificates, both generated share secrets. Okay. And then confirm that once it serves that it's finalized on the server and saying now the final it replied back to. So what the CSS? What CSS means in this context? Certificate suite. Okay. I don't know where you get that. I would like to know where you get this. What transport suite below here? But I would like to know, where do you get this? Because I think this is there you go. From Wikipedia. Oh, interesting. Okay, silly me. Silly me. Silly, very silly. Okay, from Wikipedia. Interesting. Very, very interesting. Wikipedia. Very, very interesting. Okay, good, 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 good. So, that's exactly what's happened. You know, as you can see here, the so setting a connection setting a connection base season and encrypt that, it takes now 1, 2, 3, 4, 5, 6, 7 steps before actually sending data. You know, it need to have it need to so the handshake needs to be done first, all right, to verify that somebody else is on the that address, right, and that location. If it is, we establish the syncing act, and during the act, which is sent by the client, the server receive that and now set the encryption suite, the certificates, and the server hello. The client receive that and say, okay, now let me do, and let's going to handle the key exchange. So I'm going to send you now the client exchange, the client key exchange, and let's going to now I'm going to send that back to the client, to the server. The server receives that and then sends now a final response that now it can send data. Holy moly. So with UDP, it's just based on 3 handshake, right? So Quick is also part of the HTTP protocol, all right? Or is a no, it's a UDP. Sorry, my bad. Quick is a UDP protocol. I'm navigating here because I think there you got it. Oh my god, what it is? Blah 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 blah. Holy moly. TCP. It was a particular exactly this diagram. So you have now UDP and TCP. So TCP is, for example, now HTTP 1, HTTP 2, and WebSockets, and now HTTP 3, because HTTP comes from the Quick, which is now a UDP. It comes from the UDP over, is built on top of the UDP, and also the WebRTC. So the thing here is now with TCP and UDP, right? UDP is way much more faster, right? According to this handshake of Quick compared to TCP, okay? It say, hey, the Quick handshake is just sending an initial hello. The server now receives that and send the certificate, all right? Which all of the data, so they already exchange the data. And then the client is able to send that data and finalize is a certificate and the key exchange and so on and so forth. So why am I mentioning this? you might wonder, you might ask. Well, because fellas, right? Let me actually put it here. So the OC model, right? Because this is part of the thing that you need to describe when it comes to talk about this topic, okay? So you can have an idea of what's going on here. So let's get into this. Finally, let's get into this. Okay. All right. All right. So, yep. Let's get into this. Let's get into this.
Setup, I put it in here, but the font is Mona Lisa. Here you can open issues, you can open pull requests. I'm going to ask you if you have questions, don't message me, put them on the repo, because then later if someone else has the same question, they can Google it and find it in the repo. And pull requests are very welcome, particularly because I always have a ton of spelling and grammar mistakes in my courses. So there's another course on Front of Masters, which I'll pull up really quick here, that I taught previously called Complete Intro to Databases. This is all still current and useful. This covers 4 different types of databases. This is more comparative of like, I'm thinking about this problem that I have, how should I model the data, right? And so it goes over an SQL database, which is Postgres, right? So this section here is going to largely overlap with what I'm going to teach today, but we're going to go into much more depth today. But this class also goes into graph databases, key value stores, as well as no SQL databases. Specifically, it goes into MongoDB, Postgres. This is Neo4j, and then this is Redis. So this is much more like a higher level, comparing use NoSQL for these kinds of problems, use Postgres for these kinds of problems, use Redis for these kinds of problems, right? Whereas this class is specifically teaching you in-depth SQL so that you can work with an SQL. You've already decided to use an SQL database. This one's going to help you choose that you want to use an SQL database. If that makes any sense. My name's Brian, and I work at Stripe. Specifically at Stripe, I am the product owner of the Stripe SDKs, the Stripe VS Code extension, the Stripe React Native experience, the CLI, a bunch of developer tools, right? So that's kind of the theme of my entire career. For the most part, I've worked on developer tools. Previous to being at Stripe, I worked on VS Code, and I worked on Azure. I was the owner of JavaScript on Azure. And then before that, I was a bunch of developer tools, right? So that's kind of the theme of my entire career. For the most part, I've worked on developer tools. Previous to being at Stripe, I worked on VS Code, and I worked on Azure. I was the owner of JavaScript on Azure. And then before that, I was a Node.js and JavaScript front-end developer for like a decade. I worked at LinkedIn, Netflix, Reddit. I started teaching at Front of Masters when I worked at Reddit, so that's been, we're coming up on a decade of me teaching at Front of Masters, which is crazy to think about. I've written a lot of code and queries over the years. I started coding probably around when I was 10. My brother made me write code before he let me play video games, so I'm both still upset at my brother and also thankful, because here I am. But I'm going to tell you right now that you can learn these skills at like any point, right? You can be, I'm both still upset at my brother and also thankful, because here I am. But I'm going to tell you right now that you can learn these skills at like any point, right? You can be, 60 and starting this. You can be 5 and you can be starting this. I don't know, 5. I don't know if I'm going to teach my 5-year-old how to write queries in SQL. I don't know, maybe if he's bad. When I really started writing a lot of serious SQL was my internship, where I had to like query these, really archaic and weird databases using SQL. Which taught me a lot. And then over the years at Reddit, I wrote a lot of queries. At Netflix, it's kind of been a theme throughout all my career to use SQL and various incantations. I didn't really start using Postgres until I worked at Reddit. Before that, it was mostly MySQL. But you'll see that while most of the things that we're going to talk about today are very specific to Postgres, a lot of these skills are generally applicable across all and any SQL databases. And we'll talk about that in a little bit. I live in Seattle. I like to travel, hang out with my wife and my new kid. And yeah, that's me. Feel free to catch up with me on social media. All my links are there.
Exactly.
And the last thing I always ask people is if you can give this repo a star.
This is one of the things that I asked to this. It's like, yep. So not only what's the problem that SQL solve, and I think this is quite important here, because we're about to look at now. So what's the problem that SQL solve? And the other is that, so what's the problem? SQL databases, okay, are good for, or what kind of the problem SQL exactly? You can think of this. You can think of what kinds of problem SQL databases are good for, right? So when you already know the SQL, So what kind of problems are SQL database good for? Okay. What kind of problems are SQL database good for? That's a very interesting question. For well-established relationship, so handling structured data with well-defined relationship. So handling structured data, okay, with well-defined relationships. However, the reality is that things change, bro. You know. Okay, they're particularly strong for transactional application, complex query and reporting. Okay, that involve joins across multiple tables, aggregations and filtering, complex query and reporting. So they're particularly strong for transactional applications where data integrity is critical. Okay, so when data integrity exactly, when data integrity is important, especially when you have something at risk, business risk, all right, or risk related business, all right, you want to actually do that. So banking system, e-commerce platform, inventory management. So banking systems, e-commerce platform, or inventory systems, right? So data is important. You need to guarantee the data it'll be there. Banking systems and e-commerce platforms or inventory systems. This is the problems or the use case of what SQLs are good for, right? Good. Makes a lot of sense. And because this is a real problem that it's solved, now we can dedicate our attention to this kind of tools because actually it's solving real life problems. In any case, so structured data with well-defined relationships. So complex query and reporting that involves joins across multiple tables, aggregations and filtering. SQL declarative nature make it straightforward to express complex business logic and generate report from relational data. And it's interesting because you want to express now complex business logic, and this makes a lot of sense. So transactional applications, transactional applications, all right. Transactional applications, the ACID properties that it has to. So the ACID properties that it has to. Atomicity, consistency, isolation, and durability. Ensure reliable transaction even when multiple operations happen simultaneously. ACID properties ensure multiple transactions even if they happen at the same time, parallel, or exactly even when multiple operations, the ACID property ensure multiple transactions even if they happen at the same time. Okay, they happen all simultaneously, even if they happen simultaneously, right? And the ACID property, which is atomicity, consistency, integrity, and durability, right? And isolation, my bad. Okay, isolation. That's right. Atomicity, consistency, consistency, isolations, and durability. Okay, the isolation part is something that I'm not quite familiar with, but this is something we're going to explore that. So for transactional applications, okay, when multiple queries or transactions needs to happen, and you need to provide consistency and integrity of that. Complex querying and reporting. So complex queries and reporting. Complex queries and reporting that involves joins across multiple tables. Again, this is multiple joins it involves joins across multiple tables and aggregations and filtering, but it's because you want to express complex business logic and generate report from relational database or relational data. Okay, so combine or involve or joins multiple, because this is the value proposition of this. Join multiple tables, aggregations, okay, and filtering to express complex business logic from to express complex business logic and generate report from relational data and generate reports from relational data, right? Like this. You got it. Applications require strong consistency. Exactly. Strong consistency. So the applications require strong consistency. There is no need to dive deep into that. Well-structured business data, okay? An application with predictable scaling patterns, where you can anticipate growth and optimize accordingly through indexing, querying optimizations, and vertical scaling. What is the difference between vertical and horizontal? So vertical scaling, that's a vertical scaling. Horizontal scaling, it's exactly. Vertical scaling is from the point of view of power, existing machines to handle increased workload, such as adding more CPU and RAM. That's vertical scaling. You are, and they call that vertical and horizontally because the dimension here is CPU hardware, CPU power. Okay, but it's not good for that horizontal. It's good for vertical scaling, so you can have in that particular server and database huge data sets. But when you have to sharding, when you have to now split your data into multiple ones, that's when things becomes quite interesting here. SQL databases are less ideal for highly flexible and rapidly changing data structure. Massive horizontal scaling requirement, or scenarios where eventual consistency is acceptable in exchange for higher availability or partitional tolerance. Compliance-heavy environments where you need to detail auditing trails, role-based access control, and the ability to enforce business rules at the database layer. Is compliance-heavy environment. compliance heavy environment, which is good, right? An application with predictable scaling patterns. The other is well-structured business data, well-structured business data, something that we already mentioned that. So you have now a clear order in your records, and that naturally fits into tables with clear relationship. Okay, well-structured business data. In scaling application with predictable scaling pattern, apps with predictable I don't think this is how you wrote that. Predictables, right? With predictables scaling patterns, all right? When you can anticipate growth and optimize according through indexing, query optimization, and vertical scaling. Okay, indexing, query optimization, you can optimize. So you can anticipate, you can anticipate growth. You can anticipate growth and optimize. And you can anticipate growth and optimize accordingly through indexing. So you can anticipate growth and optimize queries accordingly to index, right? Or to accordingly through indexing, okay, query optimizations. I'm not sure of it. Indexing, I am. Query optimizations and vertical scaling. This is how you can now optimize or anticipate the growth of your database. How much data is going to be stored there. Indexes, something that I'm quite familiar. SQL query optimization, I'm not. In a predictable scaling patterns. In vertical scaling. In compliance heavy environment. This is when you need detailed auditing trails, role-based access control, and the ability to enforce business rules at the database layers. So this is the kind of problem what SQL database are good for. You know, this is the kind of problem. So anytime you have a problem to store data, when that data, as long as they have clear relationship, whatever it be, okay, and you need to store that in a structured way, in this table, you need to store data in a structured way and where they have the clear relationship. So for example is banking or the natural inclinations to know the relationship is a natural fit. You have the banking, you have the inventory or e-commerce right now. So yeah, that's a good candidate for. And I think this is something that it won't change because we rely heavily on banking and e-commerce as well as the inventory to actually organize our economy or research. And this is now go beyond the scope of today's video, that talk about now economy, but you can see the overlapping between what you're doing, whatever is the problem you're trying to solve with mathematics and with computers and computations, and therefore, well, you can now receive is compensation from it. Okay, good. Jesus, this is only the introduction. But it's important to understand that, all right? And now that we are here, we say, all right, good, cool, let's get into this.
Find it, which is cool.
You know?
It also pads my ego, which needs help sometimes.
What's the secret of mastering all these skills like databases and front-end development?
That's a good question. The theme of my career is I've worked all over the stack, right? I went all the way from working on pure front-end applications sometimes. I did that at Reddit and Netflix, all the way to working on lower levels of the stack and doing back-end stuff. I did that at like LinkedIn and also Netflix, all the way down to I worked on cloud infrastructure at Microsoft, right? And now I do product management stuff and business stuff at Stripe. And the thing that's been critical to my success and me learning all these various different tools is that I learn by teaching, and that's just kind of my learning style. When you are forced, or when you're teaching, you are forced to kind of reduce your knowledge down to a common vocabulary between the person that you're trying to communicate with, which means that you have to break down these things that you kind of hand wave over in your brain, and like you have to kind of open the box and see what's inside of it and understand those primitives, because people are going to ask you questions and you have to kind of provide for those questions in advance. So in other words, a lot of it's from experience, and secondly, I've taught a lot of people both teaching workshops to my coworkers and doing front-end masters and doing conference workshops. Doing all that teaching really helps solidify these kind of basic primitives in my brain that I use to build back up into more complicated, higher level things.
Should I take the intro to databases course before this?
No.
Or?
No, so the complete intro to databases, like I said, it's kind of a different approach to a similar thing where it kind of teaches you how to model problems and what kind of database to use for each one of them.
How you can
This one
model
has
problems.
no dependency on complete intro to databases. This is its own thing, so you do not have to take that one before. In fact, if you take this one before, for the most part, you could probably skip the SQL section in the other one. This one's going to have more depth than the complete intro to databases. Yeah, testing.
Do I have to download Docker for this course?
You must download Docker in this course, and it's literally the next section.
Of course. Yeah, those kind of silly questions, and also the reason why I'm actually taking notes
So,
of my
to be-
learning process is because I know that there's sometimes some people gonna come up and ask me questions. You need to know the answer in advance. And if you don't, you already know what's the problem you're trying to solve, and therefore you can communicate your ideas much more clearly. That's the reason why I'm doing this. And I'm doing this in English because it is a language, it is the business language. It is a language in how we can now exchange that kind of data. And that we can also develop is a mindset, especially for Spanish like people like me, or for everybody, right? That where English is not its native language. I will say that you can now understand what is especially if you work in tech, you can understand now is the part of the mindset of native speaking people, right? Because it's very well oriented to business, to entrepreneur, to try to solve a problem and cash that out. Some of them, of course, actually try to do that in a non-sustainable way, I will say, right? By betting against you or by betting against another, and so on and so forth. This is part of the human nature, right? However, what I think is, what the value that I can get from is to say, hey, we as Spanish people, whoever speaks Spanish, our way of looking life is completely different, especially when you need to exchange or when you need to develop commerce or trade with somebody else, all right? And that is something that it can change. You might be somebody that can change that if you want to. because there has been like 400 years of one particular mental model to say, hey, the Spanish institution as well as the Indian institution now have a particular way of conceive life, which is come from this extractivism. They come with this extractivism where they can only care about what is on beneath the soil and nothing more. So unlike now the North, where they come up with this ideal of entrepreneurs or owning now the lands, and therefore you can now is at least exploit that land at your own benefit, and then you can grow and then promote trade. Here, well, over the 400 years, we create now is a special kind of social hierarchy where anything that they create now this aristocracy, where anything that it's saw as a manual labor were not considered worthy. Business are something that were looked with suspicions. And if you now wants to develop a particular business, you need to have contact with some part of the government. Again, this is also true, so to speak, in some sort of way in the U.S. Perhaps it's not with that huge emphasis, all right, like here in the South America, but it's something that as long as you understand that and you are willing to change that, because it's all about desire, the desperation that you know that you have to do this, well, then you're going to find that way. And I know how to make with this quick recap of as a way to tell you this story of why am I doing this, why am I actually looking at the intro to SQL and so on and so forth. But it's because of that. And most we need to know is the destination. Where are we heading to? Especially if you're going to develop a particular application, if you're going to build something, whatever it is, yada yada yada, you need to actually know that. Because it is effective. And that's why I aiming to things that are effective. So if you eat well, if you hit the gym, if you take yourself, you share with others, with your family members or other cultures, right? And then you promote traits, right? This is something that is a beautiful experiment and a beautiful way of living your life, while also recognize that you need this self-realization, that you need to know is what you are doing the thing that you do. Again, because it is effective, because it works. So let's get into this.
That.
Okay, let's go into SQL setup with Docker. I don't think that's quite hard, but we can dive deep into this. SQL setup with Docker. SQL setup with Docker. Am I thinking that they're going to do that?
Docker. This is not a Docker course. I left a link here for you to my Docker course if you want to take a Docker course, which I suggest because I think containers are really important for developers.
Yeah.
But that's not what this course is. I'm going to give you all the Docker commands, but I do need you to go download Docker Desktop, or whatever flavor of Docker. But if you don't have a preferred flavor of Docker, you should use Docker Desktop because that is by far the easiest one to use. So please go install Docker Desktop. I left a link here for you. It should detect whatever desktop you're on, and you can download it. They'll kind of lead you through all the various different steps that you're going to have to do to get that up and running. And then we're going to interact a little, actually quite a bit with the command line. This is not a command line course. There is a command line course that I also teach that would be helpful, but again, not required for this. I will give you the command line commands that you are going to
Number
need.
one, two,
So in other words, you can
load.
basically just copy and paste all of my commands
Docs,
directly, and
that
that should
Docker.
just work for you.
Okay.
If you're not familiar with Docker, Docker uses containers. A container is basically, you can think of like a mini operating system that they kind of put together for you to use.
One of the things that
We're going to be using
Docs-
2 containers, and actually kind of 3 containers at one point. But these 2 are the primary ones. The first one is just the vanilla Postgres container.
Really?
And then the second one is this kind of one that I built on top of it. So the second one actually depends on the first one. So Docker will handle that correctly. You don't have to do anything about that. We're going to be using on top of it. So the second one actually depends on the first one. So Docker will handle that correctly. You don't have to do anything about that. We're going to be using specifically Postgres 14 for this course. They actually do tend to change a lot between Postgres versions. So even if you're taking this way later from when this class was filmed and Postgres 15 or 16 is out, I will suggest that you still use Postgres 14. That way, everything that all the commands and stuff like that will work as is. You don't have to kind of do any translation. And then later after the course, then go learn what changed between 14 and 15 or 14 and 16. The second one here, you can click here. It's just a container that I put up on Docker Hub called Complete Intro to SQL. It has 2 different databases seated in it. It has the Open Movie database, which is a huge database with a bunch of put up on Docker Hub called Complete Intro to SQL. It has 2 different databases seated in it. It has the Open Movie database, which is a huge database with a bunch of movie stuff in it.
Okay.
And then there's another one for a website that you and I are going to build called Recipe Guru. Just know that I'm going to have you download some of these containers. They are quite large, so if you're on like metered internet, you might want to find someone that's not metered. Each one of these containers is about a ½ gigabyte. So I'm going to have you download about 1 gigabyte worth of stuff. You can run these now. This is actually going to go pull these containers. It's not going to run them yet, but it'll download them onto your computer. And then once you've done that, I want you to grab this command right here. And we're going to just paste that into our command line here. So I'm just going to paste docker run. You can see I give it a post. This is E means environment variable. So I'm going to give it a password of.
So let me actually is create this one, my friend. So, was already download that. I want to create now a folder here. Warp. You got it? See the website from scratch. I want to create a new one. Then I say cd frontend master. I want to create now a new one. Make dir of the SQL 3 course, SQL and Postgres. You can say complete intro to SQL, complete intro to SQL and Postgres. Okay, it's a hey, I cannot create that. Why not? Because that's not the valid. You got it. Complete into the Postgres, and here we go. We can now init this repo as it is. Awesome. And there you got it. Right. So we already have Docker. I think we can check the Docker version. No, we don't have that. That's interesting. I already have Docker desktop here. Oh, the daemon was not there. Download because you download from the internet. Yeah, I do. System settings. You might yelling at me and say, "Hey, what the?" I accept the terms and conditions. User recommended settings. Require password. Good, no problem. All right. So now it's installing that behind the scenes. Work email, personal, EA. I do have a Docker account. Yep. I do have a Docker account, which is this, right? I can open that up, paste the password here. Proceed to Docker desktop, please. Be my guest. I'm a full stack developer. What will you use debugging for? None of your business. And alright, here we are. We already download that. Let me actually it is personal. Good. Let me close this and close now this one. We already download that. We need to actually check if we have that Docker. We already have that. The question is that which version of Docker are we using? It seems like it doesn't matter which version. Okay. It doesn't matter the Docker version we have. All right. And then we need to pull that Postgres as it is. Say Docker pull. I want to pull that image from Postgres. Here 14 Docker pull Postgres, right? So I want you to look at this. I think we can do here with warp. That's right. Let me rename this to say warp, or to say SQL. Right. There you got it. We already installed Docker. Okay, we got Docker. And we got the 28 version of Docker, 2 AP version.
You can see
In my case, it doesn't actually show me the node version. The node version they're using is version 16 on Docker. All right.
You give it a post. This is E means environment. Very.
All right. And we're going to use now is let me pull this Docker 14. All right. I don't know which version of SQL they are using. That'll be quite interesting. Do you know that? Right. What's next? Holy moly! It actually autocomplete that. Good, but I don't want you to do that because the next thing is I want to download this image. All right. That hole is now the server here. We're going to connect is with Postgres only, exactly. BT holds complete intro. So this is BT hold Brian. Okay, Brian hold complete intro. Say complete intro Postgres 14. Complete intro to SQL 14. Okay, complete intro to SQL 14. Let me see if the image still exists and say, hey, no, I couldn't find that. Pull BT hold Okay, slash complete intro to SQL. Complete intro to SQL. I don't think that image is still available. Right. That's interesting. Okay. Using default latest tag, it exists. It downloads that by chunks. You know, all of these chunks. And now we get it. Good. Awesome. Awesome. So you download this new image, right? And make sure that you are working run on the following, which is Docker is all of this. So I want to have now the experience, the tactic experience here. Docker run e Postgres. So say Docker run e Postgres. Say okay. Postgres password. I think this is more relevant to the Docker image. We go to the Docker image Postgres 14. All right. Image layer details. There you got it. This is just to get myself familiar with that. Vulnerabilities 15, 43, 41, 26, and 1. Holy moly. That's interesting. It doesn't allow me to check other ones. So, okay. What is this? This is the latest. Which version they are? In 17. Good. All right. Question. Because they have now is this one. The version they're using, okay. What the French stuff is this? Exactly, you. The version they're using is MySQL 5. So you have now MySQL. MySQL. That's right. And which current version? You have now 9 version. Okay. And they were using is now version 5 of that. Okay. When was the last time? So MySQL 5. You can ask when MySQL 5 was launched. All right. In October 2005. Holy moly. Oh, crap, man. These people stuck in the past. And a lot of companies are now, well. You know, it's like, well, they should update them, man. I am not the one who tells them what to do. This is their business. This is their application, you know. It is up to them. In version 6, in 2009, in version 7, in 2018. There was a lot of that. Who's responsible for updating that? I don't think people will do that. The mainline MySQL server, however, skipped versions number 6 and 7 and jumped directly to version 8, which was announced in April 2018. Holy fuck! Okay. Jesus. 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 Okay. All right. Oh. Oh. Go, 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 go. Oh. Holy. I mean, so they're using is a latest version of MySQL. Close to, close to, because here I look at something like this. Holy moly, bro. What is the, okay, tags. What is the 0.5 version? Oh, but this is from Oracle. Of course they have that. Exactly, but this is the version they're using. 5.7. 5 points, exactly. MySQL 5. Interesting. Exactly, but this was a recent version of MySQL. Holy moly, what the fuck? Five 5.7. Holy moly. Okay, so another way is to download that. Try HeatWave for free. HeatWave for free. Come on, man. What if I want to download that? That's interesting. You can download now. Okay. But I want to download is not the newest version. I want to download is a 5-point version. Oh, they don't have available that? Okay. So if I want to install previous version, Oracle is the maintainer of this. I get it. Okay. So what if I want to download is not the newest version, but holy moly. Servers, partners, customers, why MySQL? Of course. Errol Bank, Uber, Sunny. How to buy. MySQL Docker. MySQL 5 Docker. Okay. And I think they don't have that. Exactly. That's what they use now is the MySQL or the PHP MyAdmin. Okay. Exactly, but this is a particular version of this. You know? It's because nobody actually is maintaining that, bro. Nobody's actually maintaining that because, yes, you need you need a computer. Okay. So okay, no, but again, all what I want to do is to understand now how you can use access to a SQLite database. All right. So this is getting running. So check out the setup. All right. Check out the setup. And once we install that, we're gonna do is this. Again, this is something very narrow specific to how you can have access to that Docker instance. I already pulled that up. I want to know is the Docker here. I don't have any container running because I are only exactly. I only download those images, and then I want to do is, well, get into this. Okay, cool. So, let's get into this. Let's definitely get into this. All right. So if I want to read more about this, I just want to take a look at the Postgres. Okay. Postgres Docker is similar to the SQL Microsoft Server. Especially at their that's also great. Thanks, bro. SQL Server Locals. And the intro to this. Descarga, comunidad, recursos, products, and research. Fin del soporte SQL. Oh shit. SQL Server. Real Bank of Canada. Opciones de migración y modernización. Cambio del hash. Utilizar localmente. Which server they have? The SQL server? Yeah. Okay. But they're docs. Reference manual. Okay. And all right. And this is release notes. No, but this is release note. Okay, no, but I'm looking for the documentation. MySQL reference manual, include MSQL that. Reference manual, that's right. Exactly. Holy French toast. Installing and upgrading MySQL. Oh, installing and updating. Determine your current MySQL version, and then you can have access to that. Okay. Go. C functions, command index, join types index, SQL model index, privilege statement syntax index. Statement syntax index. That's there you go. Alter database, alter procedure, alter schema, alter table, analyze table, backup table, alter view, begin, end case, master to begin, catch index, check table, commit, create database, create an index. Okay. Create table like, create table select, triggers. Okay. Good. So, all right. It's quite not developer friendly, not at all, but it's a specification that works. And then you got this select for all of this. C API data structures, C API functions overview, field offsets, and all that kind of stuff. This documentation is for an older version if you are. Yep, which is 5. Okay. Another good example is that use this to feed that and then ask question when I need to. Ref manual, this is the SQL ref manual for that, and I can drop that into claw. Let me actually do this. Let me drop this claw to this. It will be my agent here. You'll be my agent here. Okay, but you get this. You get this. Get Docker, increase productivity and efficiency. Move on.
And we're going to just paste that.
Yeah, let's go to paste this. But I want to, instead of doing that, I want to have more a physical sense of what I'm doing. So this is Docker run.
Into our command line here. So I'm just going to paste Docker run. You can see I give it a post. This is E means environment variable.
Variable environment.
So I'm going to give
exactly
it a password of LOL.
Okay. Part of the environment here. So Postgres password. But okay, this is part of the variable environment here. You can say hey LOL. Followed by the name of this instance.
Because
FPG. Okay.
it's really easy to remember. Obviously, don't make your database password LOL in production. Not at all what I'm advocating. This is just something that's really easy for us to reference later. We're going to call it PG as in Postgres, just because that's really easy for us to reference later. The --rm means once this container is concluded, remove all of the logs and stuff like that. Don't leave that stuff floating around.
Okay, this is the end of the flag. Once this container is removed, delete all of the data associated with that.
The -d is detach, which means run it in the background, don't run it in the foreground.
Okay, so I want you to detach, run in the background, not in the foreground, in the forefront.
The -p means expose this port, so we're going to...
And -p is being exposed the port. Okay, in this case is the 5432, the same port that is natively run. 5432, 5432, that's right.
We're going to expose 5432 to our local computer. Postgres is the name of the container, and the 14 is the version.
Postgres is the name of the container that I want to run, and 14 is the version. And we put now here a name PG for the instance of this image here. Okay.
So I just explained it all to you so you're aware, but you actually don't need to care at all. You can just copy and paste it and say, I don't care what Brian says. That's fine. You should get something like that. That's the hash of the container that's running. And now I should be able to say Docker PS, and you can see
Then
here
you
I
can say
have my container running. It's been up for 7 seconds. Its name is PG, and it is running on port 5432.
What?
So
5432. If I say Docker PS, I don't see them.
container running.
Alright, that's quite interesting. I don't see them. Postgres password LOL. Despite that I have this hash, but I don't see them, which is quite weird. So if I go to Docker, if I open up the Docker dash here, it say, hey, you should have now the 2 image, but not running it. What? This is my season exactly, but it's not running it. What? Okay, let's go to copy this, for example. That's my blowing. Docker run with the environment here and say Postgres password lol name pg. Once you delete this instance, I want to delete all of this. Detach will say, hey, run in the background, not at the forefront. The port I want to expose and the version that I want to use. And if I do docker ps, now I create that. What was the main issue here? Docker run. Postgres. Exactly. Yeah, my name. Yeah, I know what was the error. Okay.
It's been up for 7 seconds. Its name is PG, and it is running on port 5432. So going back, I just want to give you enough Docker information to be dangerous. So right now we have Docker PS. That'll show you everything that's running. If you want to stop it from running, you can just say Docker kill PG, and that will stop it. So now if I say Docker PS, it's gone. And again, I can run it again. That'll start it again. That's all goodness. The one thing that I wanted to say about running Docker kill, it will delete everything that you've done. So if you've been following along the course and you're like halfway through it, and you've run Docker kill, it's going to drop everything that you had. So just be aware of that. So that's both a good thing if you're trying to reset and start over, but it's a bad thing if you didn't mean to drop everything. Docker's really good about just running quietly in the background. So if I just close my laptop and come back, the Docker container typically will still be running. But if you restart your computer, for example, it will kill your containers. You could fix that by running, if I just close my laptop and come back, the Docker container typically will still be running. But if you restart your computer, for example, it will kill your containers. You could fix that by running volumes in the background, but I'm not going to show you how to do that today, so just be aware of that. The thing that you can always do, the complete recipe guru database that we're going to build up over time lives inside of this complete intro to SQL one as well, so you can just pull that one and start from there as well. Yeah.
What does it mean to run the Docker container in the background versus foreground?
That's a good question. I can just show you really quick. So if we do this Docker run and I just take this -d out,
so you're gonna see
it's actually going to start Docker in the foreground. Like you can see all of the logs running immediately right in front of me, right? Now I don't want to do this, right? I just want it to run in the background and not think about the actual execution of it. But if this is useful to you and you want to see all the logs from it, this is how you would do it. What's hard about this, if I say Control-C or if I close this window, it's going to stop the container, right? So you can see there, I actually shut it down. It's not running it anymore. But if I do this and I come back here and I say -d, it just runs it in the background, and I can kind of just not think about it anymore. The last thing I want you to do here is just copy and paste this one.
I want to access to this. All right. I can now have access to that. So after you install Docker, after Docker is installed, and after Docker and the image are installed, are download and install. All right. Then this is the two commands that we need to run, and this is to actually access to the instance. Docker exec.
Docker exec. If you run this, you should just immediately get a session of being connected to Postgres. So you should see this Postgres prompt here. If you do /L, it should tell you all of the databases that exist.
So I want to
in your
have
database, which we only
access to
have the 3, Postgres, template 0, and template 1, which we'll talk about here in a second. So what that command did, this Docker exec, this is basically saying, hey, run a bash command inside of the container. The -u means run it as the Postgres user. -it is...
It's I want to run these bash commands inside of this instance. Run with the Postgres user. Make it interactive.
Interactive. PG is the name of the container, and PSQL is actually the name of the command that we're running inside of the container, which is the Postgres client, right? PSQL is the client to run queries against the database.
In this case, is that. We're gonna run one and second one. So exec. So this will create a Docker instance of your Postgres version 14, right? And to access to the actual server, we run exec that run a bash command inside of our container with the username Postgres and -it to make it interactive, the name of the container pg with the query client PSQL.
So I can type exit here, and the container is still running, right? Because we're not actually ending the container, we're just exiting our session with the database. So anytime that you want to connect to it, you just run this docker exec-u postgres pg psql, and that'll put you inside of the container.
And then if you want to have access to that.
Now that we've gotten over all the Docker stuff,
Okay.
let's go ahead and chat about SQL. So, Mark, you had a question?
Yeah, since Postgres is such a stable, long-running software, what kind of things would change between versions? Like, I'm assuming SQL is not going to change the language, but
Yep.
what types of features would they be changing?
Cool. So yeah, like what's changing from version to version on Postgres? Super valid question. So the first thing to know about SQL and Postgres are kind of different things. SQL is a standardized language that exists across not just Postgres, but it also applies to SQL Server, Oracle database, IBM DB2, MySQL, MariaDB. There's a bunch of databases that all use SQL, and there's one single standard language. You can kind of think of it like JavaScript, right? JavaScript is a language, but there's different runtimes that run JavaScript. There's Node.js, there's the browser, there's Deno, there's now Bun, there's Rhino, there's JerryScript, right? They're all using JavaScript, which is the name of a written language, but something different is executing them. It is the same thing with SQL and Postgres. The interesting thing about SQL and Postgres and all these different permutations is they all kind of have their own flavor. Despite the fact that SQL is a standardized language, they all take their own different approaches to it, and they all add their own features to it. So a great example of this is we're going to talk about down in quite a few lessons. There's one here called like JSON-B. This is not a part of the SQL spec. This is a Postgres only thing. So that's what changes between versions is they're adding all these cool new features that are specific to Postgres, and they're making refinements and they're trying new things. Like once we get to JSON-B, you're going to see like why wasn't I teaching this the entire time? Kind of spoiler alerts right there, but. That's what's changing, is they're adding new cool features, and they're still innovating at a pretty rapid pace. Particularly Postgres I feel like is leading the pack, which is why I chose to teach this one over MySQL.
Postgres,
mostly.
I think, is leading the pack.
So now's as good a time as any to address the SQL SQL elephant in the room. What is the correct pronunciation of SQL? Well, it depends on who you ask. I did a decent amount of research on this because I was positive that someone was going to ask me. The correct pronunciation of SQL, according to the body that defines SQL, is SQL. They pronounce it SQL. However, the people that make SQL Server, aka Microsoft, calls it SQL Server, right? One of the most well-known people that works on defining what SQL is and writes all these books about it, she calls it SQL. So in other words, SQL is probably, by the most definition of that, the defining body calls it SQL is probably the most correct, but SQL is equally valid. I call it SQL because that's just what I've always called it. There are other people that will always call it SQL. But I think generally my rule of thumb is if I'm talking about MySQL or Postgres or one of those, I generally say SQL. And if I'm talking specifically about SQL Server and Microsoft Stack, I will call it SQL because that's what everyone in that community calls it. Basically, Microsoft and Oracle have codified SQL. So if you're talking about Oracle as well, they call it SQL in their docs. Basically, everyone else that I'm aware of calls it SQL in terms of like it's PostgreSQL, MySQL, MariaDB calls it SQL. So they're both correct. Someone will get really opinionated
different
about it. And you just
flavors
tell them
of
that
that.
you don't care because it does not matter. We're both talking about the same thing. There's a really interesting history about it, but suffice to say that SQL was invented in the 70s. It was derived from a language called Square. They tried to call it actually literally SQL, SEQUEL. That was some acronym. That was the name of some fighter jet or something like that, so they couldn't call it that. So they ended up calling it Structured Query Language, SQL, and we ended up with that. A fun fact is that my dad actually used to work on SQL databases. He worked on DB2, which is the IBM flavor of it. They still sell DB2 these days. And then he ended up being a technical salesman for IBM for years and years and years. This is actually stuff I ended up growing up around, which is the IBM flavor of it. They still sell DB2 these days. And then he ended up being a technical salesman for IBM for years and years and years. This is actually stuff I ended up growing up around, kind of unintentionally. It's really funny to my dad that he did all this stuff for all these years, and now I'm teaching it to people. So, fun fact. Hi, Dad. He might be watching. I don't know. Let's get into structured query language, SQL. And again, you can call it whatever you want. I will never correct you because I profoundly do not care how you pronounce it. And it's one of those things that people choose to die for no apparent reason.
Yeah. That makes a lot of sense.
So, we're going to get started on tables, not inserts. So if you're not already, please get to running inside of your container.
Yep.
You should see something here like Postgres, like that. If not, you can go back to the previous lesson. It will show you how to do that.
So you can either use
And
access
let's
to
start running some
MySQL.
commands. So again, we are interacting with the Postgres database with a client called PSQL. Those are different things, right? One is a database, one is a client that is sending queries and getting information back. So I could be hosting one database and everybody else could be querying it with their own PSQLs, right? So you have one database, but you could have many clients to it. This client has a bunch of built-in kind of helpful commands, and if you forget what they are, you can hit \\. And this will just pop up a really helpful sort of help information that'll show you a bunch of stuff. I use it all the time because I can never remember all of them. But there's a bunch of helpful commands, and if you forget what they are, you can hit \.
Oh, okay. Okay, this is the
And
way
this will
of
just pop
how
up a really
you get started
helpful
to interact
sort
with
of help information that'll
Flash
show you a bunch of stuff. I use it all the time because I can never remember all of them. But there's a bunch of stuff here. You can run commands out here. So if I do
connection formatting,
\! That'll allow me to run a bash command in the underlying
large objects.
bash. Sometimes that can be helpful. You can like cat in files and things like that. We're not going to be using that today, but there's a bunch of stuff you can do with it. That's anything that you see prefixed with a \\ that's going to be a feature specifically of PSQL and not necessarily of Postgres
and
database.
summary less command.
One that I find myself using a lot is \l. This will show me all of the databases, necessarily of Postgres database. Not going to be using that today, but there's a bunch of stuff to run a bash command. You can run commands out here. So if I do \! That'll allow me to run a bash command in the underlying bash. Sometimes.
Oh, but it's interesting because this is very narrow specific to the PSQL. Okay, one of them is the bash command.
I use it all the time because I can never remember all of them. This will just pop. This client has a bunch of built-in kind of helpful commands, and if you forget what they are, you can hit \!
Exactly, because we're talking about the client.
And this will just pop up a really helpful.
Exactly, we're talking about is a client SQL overview. This is the SQL overview. All right, but SQL overview with Postgres. With Postgres. And creating a database. In creating a database. SQL overview and creating a database. So here we're looking is at the command. Exactly. SQL overview and creating a database. But here we're looking is now helpful command for the
It has a bunch
client.
of built-in kind of helpful commands, and if you forget what they are, you can hit \\? And this will just pop up a really helpful sort of help information that'll show you a bunch of stuff. I use it all the time because I can never remember all of them, but there's a bunch of stuff here. You can run commands out here. So if I do \! That'll allow me to run a bash command and the underlying bash. Sometimes that can be helpful. You can like
For
cat in
help.
files and things like that.
Help
We're not going to use that today, but there's a bunch of stuff you can do with it. That's
command.
anything that you see prefixed with a \\ that's going to be a feature specifically of PSQL and not necessarily Postgres the database.
Exactly.
A bunch of stuff you can do with it. That's anything that you see prefixed with a \\ that's going to be a feature specifically of PSQL and not necessarily Postgres the database.
Okay. So, commands for PSQL, right? The Postgres SQL. Interesting. Specific to that. Anything with a backslash. Exactly. So anything in this case with that, okay, makes sense. So anything with a backslash is a command for PSQL. So this allows you to run now bash script.
One that I find
PWA. So this allows you to run is now bash script here. So echo path, for example, because this is part of the instance that is inside of this. You're actually running is a particular server that hosts that. Okay, makes a lot of sense. So you can say is spring working directory. You're in the root. That's right. You can also say is list all the elements. And exactly, you can see you are now in a container, aka a particularly at their own computer, all right, that is running this. Okay. So for help, all right. But this help is for what? Because you see this. Show help on bash commands, options, copyright, general, show Postgres, usage and distribution, everbest copy, / perform the SQL copy with data stream with client, input and copy, conditionals, informational, and list roles. Oh, but this is very specific to that. Formatting. I get it. Variables, operating system, change the current directory working. Exactly. Is this particular client that you can interact with that? Okay, you can say list view in the end. Oh, interesting. List table view and sequence. Okay. List domain. Again, this is the bash command. Okay. Or we can now run some bash commands on top of that. You say, hey, I want to run now a bash command. If you say here, if you say, for example, this exclamation mark, where we are, what? Oh, I think exit. Okay, we're getting here. Okay, but this is from the client. Okay, good. From the client here. Interesting. Okay, for the client here, and then you want to run a command, execute command in a shell or start interactive shell. Interesting. So helpful command. Helpful command. This one. Okay. Run bash command. Run bash command. Okay, that's interesting.
And my stuff using a lot is \L. This will show me all of the databases that exist. And I'll use
Exactly, because we are now looking at the bash command from there. Show all databases. Okay. Okay. But again, we're getting familiar with this. Come on, man. Show me all the database. Exactly. We're getting familiar with this client.
/D quite a bit.
Okay.
We haven't
Pretty
created any
much like
tables
that.
yet, so it will not find any. But \D will show you all of the tables
Graph
and
client,
sequences
so on and
and
so forth.
constraints and stuff like that. So that's a good place to get started from there. So we have a bunch of default databases. You can see here I have Postgres, I have template 0, and I have template 1. So the first thing to say is, what is a database? Are we connected to a database? It's a bit of a conflated term. In this particular context, when I say we're connected to the Postgres database, it means I have my Postgres server running, and there are multiple databases inside of this. You can think of a database in this context as a folder, right? It's a folder that contains many tables, right? Which you can kind of think of like spreadsheets, right? So Postgres here, or template 0, template 1 would be the name of my folder that I'm in. In a moment, we're going to create our own database or create our own folder. But a database contains many other tables and things like that. Okay. As you can see here, your database comes with 3 of them pre-created. So the Postgres one exists solely as the purpose. It's the default database that you connect to if you don't give it anything that's like you're trying to connect to a specific database. It just exists for that purpose. It's the default one. You can technically delete it. There's no reason that you can't delete it. You also don't have to. That's up to you. So template 1 and template 0 exist for the fact if you are creating and deleting a bunch of databases and you want to have like a template to start from, you would use template 1. You would make a bunch of modifications to template 1, and that'll affect the default database that you create. If that gets all out of whack, what you'll do is that you'll then clone a new template 1 from template 0. You should never modify template 0.
Okay.
And this is basically all stuff that you can totally forget because I never use them. This is why they're there. This is why they exist. But I never use the templates. I always just create everything from scratch because I don't find myself creating and deleting a lot of databases, right? I generally just create my database and then just go from there, right? So, but I want you to know why they're there.
Okay. It's important. This is how you can list all of your databases here. All right. For example, like this. So when you run the command, it actually comes with these 3 predefined layers here. Okay, interesting. What are you doing? Is this one? Okay, makes sense. Makes sense. But all of this is because we are interacting it with the PSQL. We're not even running any command. We are not even in the Postgres in it itself. All right, we are not even there. And here describing is this 3 stuff that I find that are quite important. Exactly, default databases. So this is default databases. Please remove any format that you might have here. Exactly. So you have now default databases. You have template 1, and you have template 0. So Postgres and Postgres here, and Postgres exists for the purpose of a default database to connect to. We're actually connected to it is default since we didn't specify a database to connect. And you can technically could delete it, but there is no reason to do that. And there is a lot of tool indexation to rely on being there.
Okay, that being said, we are going to run this command, right?
But we need to get.
So I'm going to say create.
Oh, okay. Interesting. Look at this. So this client allow us to navigate through the Postgres instance and run now SQL command. Okay. That's good. Okay, cool. PSQL, PSQL is a client that allow us to navigate through our Postgres instance, and run SQL command. Right? Exactly. Exactly. Connect to a PostgreSQL database, local or remote, execute SQL query and commands, and navigate between schemas. Exactly. It's like now execute SQL commands. Format and export query results in various ways. As your primary tool to interact with PostgreSQL database directly, whether you are doing development work, database administration, or just exploring data. Okay. Okay. Makes sense. So, allowing us to navigate through our Postgres instance to our Docker instance, and run SQL commands. Okay. Now things are more clear.
Database.
And now
Recipe
we're going to
guru.
do that. Create a database.
So a couple of things to note here. Now I can say \L, and you can see here we have our recipe
And
guru.
look at this, it has now particularly encoding the way of how now the string are represented using the UTF-8. It has a collate and C type. What is a collate and C type? What is a collate? So what is a encoding, a collate, and C type? What is encoding? I know what it is. Collate and C type. In a Postgres, in a Docker Postgres instance. Setting controls, how text data is stored, encoding is in that. This is how it's going to be represented there. Whether it is ASCII or UTF, this is the most common choice and support all Unicode characters. Collate, it's a determining how text is stored and compare. How text is stored and I want to do this. Absolutely. So if I do this, \L, and I have this, I haven't created that, and say create what? Just to be on the same page. Create database recipe guru, create database recipe guru, right? With a semicolon, you got it, and then you say with L, and here we go, right? We're ready to create our first database. So you can think of this as folders. So we create our first database here. Okay. Create a database. Right. This is our first image here. And it makes a lot of sense here to say this one. You say, okay, but so what is encoding, collate, and C type, right? Access privilege. Character classification and case conversion rules. Okay. So encoded defined as a character set used to store data. It's how the data is going to be represented, you know? So defines, so encoding defines the character set that is used to be stored data in our database. This is the representation of text data in our database. So most common is UTF. The other is determining how text is stored and compared. Collate says defines or determines how text is stored and compared. Control string comparisons like order by, greater or minus, etc. Examples of UTFs: C and POXes. C or POXes provide faster performance but basic ASCII only sorting. Local specific collation is the way how text is stored, is sorted and compared. Okay, this is one of the reasons why you need to learn about this stuff like that. You know, it's like, hey, how you gonna sort a bubble sort? You gonna do a bubble sort, that kind of stuff. But it's this. This is how text is stored. No, is sorted and compared exactly. Holy moly. Local specific. This determines how text is sorted and compared. And you might see, this might seem silly, but it's huge, bro. The character set to store text data in a database. Okay. How am I going to sort and compare this? Provide proper sorting for that language region. Here we're using is now the language region here, which is in US. Okay, for sorting and compare. For example, using order by. Okay. So you have now order by. Exactly, order by, and that kind of is that order by. But it needs to be order by. It have to be close. Okay, order by, greater or less, and so on and so forth. But this in text. Okay. In C type, define character classification and case conversions rules. Determine what constitutes letter, numbers, what space, etc. Classification and case conversions rule. Okay, C type determines classification, classification. Exactly, determines the classification. In case conversions rule classification. What is a number? Letters, white space. What is a number? Letter, white space. Determine classification. Okay. What constitute exactly? So what constitute a number, letter, and so on and so forth, right? In case conversions rule affect functions like upper, lower, and any cap. Usually match your collate settings. Usually match your collate, the way how you sort and okay, the way how you sort and compare. And C type is the classifications and conversion rules. In conversion rules. So for example, to uppercase, to upper, to lower, any cap. So upper, lower. There's another one which is init cap. Okay. Lower, init cap. Okay. Interesting. Okay. It determines how the data is going to be stored. It determines what is the character set that this data is going to be stored. It determines how the data is sorted and compared. What is the data set? What is the character set that we're going to use to do that? And what are the classification, or what determines is a white space, exactly, a classification of determine classifications or character classification determines character classification. What's constitute is a white space, a number, interesting, a text or a date as well. Okay, holy moly, bro. The C type or local type. Related local. For that you might need different local settings. Local settings. Character classification. What's the layer, digit, punctuation, etc. Okay. But it's determining is the character classification. Oh no, again, it's completely no. This is a word, not a character. Okay. LC type, numeric. Okay, it's a character. Exactly, not the words. It's a character classification. And what is a letter? Okay, what is a letter? What is a punctuation sign? What is a number? A white space. Interesting. And the conversion rules. Holy moly. When it comes to date, that's a different thing. They are related locale settings that do affect dates. Okay, but this is character set. Okay, not values, characters. Interesting. Okay. Okay. Okay.
Hence the name Recipe Guru. Now you might have seen there that I said in all caps here, create database like that. Why did I do it that way? Why is it all caps? Well, the reason why I do that is so that you can see the commands that are coming from SQL are always going to be in all caps when I do them for you, and everything that we do that's like optional user-controlled information, that's going to be in lowercase here, like Recipe Guru.
Exactly. Is anything with a backslash in the command is a PLC command, and anything in uppercase is a SQL command. Okay. All right.
That's a very common pattern in SQL, but there are also people that insist that you should never do caps, and it's really dumb and people are wasting their time and, pinky strength by holding shift down for so long. And again, it doesn't matter. I like it. Whenever I'm writing code, I tend to do everything in all caps, so it's really easy for me to glance at. It's like, okay, create database, that's a command, recipe guru, that's the name of the database. And it's really easy to parse that visually, but there's no requirement that you have to do that way. I will find myself when I'm just writing queries just to write queries, I'll probably not do caps just because I'm lazy, right? So that is totally up to you, and it's one of those things like SQL versus SQL, it really just doesn't matter. So it's never worth getting into an argument with anyone over it. So I'm just going to throw out here one more note that if you kill your container at this point and you restart the container, you will have to recreate recipe guru again because it's going to give you another blank slate, right? It's just another word of caution that I'm putting out there. I do provide here this complete SQL file. You can actually download this. This will actually be the complete recipe guru. So this will give you actually the first half of the workshop already done, if you need that. Or you can use the container from Docker Hub, which is the this one here, the complete intro to SQL. And that will also give you the complete recipe guru database. So a database is a collection of similar tables. For all of our recipe apps, we'll be storing them in one database. People ask me frequently, when do I use multiple databases? When do I just shove everything into one database? That is a very you call to make. In general, I tend to shove a lot of things into the same database because I don't really see the use in trying to make them work across databases. In particular, if anything would ever have to be related to something else, like I have my ingredients, I have my recipes, those obviously have to be connected to each other, right? Those have to be in the same database, no matter what. But let's say I have user session information and I have recipes and ingredients. In theory, those could live in different databases because I would never have to collate those two together, right? So it's a highly opinionated thing, right? It's kind of like asking the question, should I have two services or should I have one monolithic service, right? Should I have microservices or macro services? That depends on what you're doing. For your purposes, getting started, just throw everything in a database and in general you'll be fine. The question you can kind of ask yourself is, would I ever have to scale these things independently? Which is where it can be useful to be split across databases. So you can see here I created the recipe guru database, but I am still connected to the Postgres database. So I want to switch my connection. So I'm going to hit /C
to manage
recipe, and this actually does have tab completion. So I can hit /C recipe guru, and now you can see here I'm connected to the recipe
for management
database, which again has nothing in it. If you put /D, you will not find any relations yet. But we're going to go on to the next lesson. We'll actually create some tables. So let's create our first table. We're going to be creating an ingredients table. So you can see here, let's just run it, and then we'll talk about it. So you can just copy this, or we can even just type it out a little bit so you can actually kind of get a feel of what it feels like to type it. Create table, ingredients, and it's going to have a couple of things in here. So we're going to have an ID, which is going to be an integer, or you can put integer like this, or you can just put int, it's the same thing, or int4. I don't know why that would ever be the one that you would choose, but you can choose that. Int is a primary key. It's generated always as identity. Okay, then we're going to have a title. It's going to be a varchar, and we're going to give it a length of $255. It is unique and not null.
Okay, but this is not creating and populating a table. But so far, so good, because that'll be all for all of this particular knowledge that we have learned from. So that'll be all for this video. Take care. Bye-bye.